All right, great.
I'm going to speak today about our shift left security with infrastructure as code. I'm working for Visma, which is a federation of 200 companies operating across Europe and Latin America, and we are delivering ERP solutions, most of them being in the cloud. And I'm here today to speak about shift left security. For those of you who do not know what shift left security is only a method that helps us to focus on security from planning our system before we are going to arrive into production, where most of us we are focusing on security. And for the DevOps lifecycle process, we start shift left with the planning, where we have threat modeling, and then we are going to code, where we have dynamic and software application security testing, and so on. Now in Visma, we have decided to split our assets that are bringing business value to our company in 4 categories, one of them being the application. And we are offering our teams the possibility to use different security methods for shift left security. But one of the problems was that we were focusing a lot of the application code, while the infrastructure became code as well. So we started to see if there are security risks when we are using infrastructure as code. And from what we have seen in different reports, there were like a lot of insecure data transit, misconfigurations, network misconfiguration, a lot of publicly exposed resources. So we said that we should adopt this in our company as well. So our goal was to find a tool that can be adopted by our teams that are using different cloud platforms. We had like 22 teams having their workloads on Azure, AWS, and GCP. We split them in function of their size to see how they are performing in terms of vulnerability, if they are like a big team or a small team. And we have looked with each one of those tools, Snyk, Kix, and Chekhov, how they are performing in terms of file scan. So we have looked to ARM templates for Azure, we have looked to Terraform, and we have looked to CloudFormation. And we have seen that each tool has different results in function of the file type. What we have discovered, that there were a lot of publicly exposed resources, a lot of unencrypted data, and a lot of IAM policies that were wrongly misconfigured. Most of those misconfigurations were due to the default configuration that were in place by the cloud platform. Like in AWS, everything is closed. In Azure, everything is like open. While in Azure, everything is encrypted. In AWS, you have to choose your client encryption keys, or it was like that last year. We had no hard-coded secrets and in the code because we have a strong security culture when it's coming about secrets in the code. And what we have seen that infrastructure as code is not covering is the infrastructure built with PowerShell and bash scripts, because there were teams that were using also those kinds of scripts to create their infrastructure. Infrastructure as code is not covering the drift. So if someone is doing a manual modification and not via the code, you are not covered for security. You cannot know if your unencrypted data is PII, PCI, PHI, and so on. So for this, you will need a more full security cloud solution, which is like from the CNAPP platform. What's next? Of course, we decided to adopt this in our cloud delivery pipelines. And we started to look into what we can prevent in the design phase of our systems. So learning from the vulnerabilities discovered the infrastructure code, the coding phase, and the runtime phase, we thought that we should take them into account when we are designing our infrastructure. What we have learned more was that node blaming teams, they will be open with us and trust us. By involving the teams in this process, this boosts the security knowledge of the team. They understood better their infrastructure. And in other words, we involve them, we train them, they became our ambassadors in the company on the subject, and other teams adopted the program. Thank you all, and thank God.
All right.